Hello everyone, my name is Aarohi and welcome to my channel. So guys, in my today's video, I'll show you how to perform object detection on a custom dataset using YOLO11. So first, let me show you the dataset which we are going to use for our today's class. So I picked the dataset from Roboflow universe, and this is the dataset license plate recognition. And guys, if you want to use this same dataset, then just click on this dataset over here and then select the model. So we are working on YOLO11, so we need the annotations in the format which YOLO11 accepts, right? So just click on YOLO11 and here just select this one. What we want is we want to download the zip file to our computer, and then we'll use those images and their corresponding annotations to train our YOLO11 model. And then just click on this continue. After that, you'll see that in your downloads folder you'll see this kind of zip file. Okay, we'll unzip it and then we'll use it. So this is how you will use the dataset. But guys, let's say if you don't want to use the dataset which are readily available, you're working on some sort of problems and the related dataset is not there on the internet, and you want to work with your images and you want to annotate the dataset yourself, then what? So first I'll show you how to annotate the images in the format which YOLO model accepts, YOLO11 model accepts, right? And then we will train the model. So let's start with that process, like how to annotate your custom images. Drive, I have a folder with the name of YOLO11, and inside that I have created this folder, demo custom YOLO11. So we are going to work in this folder today. So this folder is empty. I'm going to show you each and every step how to perform this custom object detection step by step. So the first step we are going to learn is how to perform the annotations on the images which YOLO11 model accepts. So the name of data annotation, and inside that I have placed these few images. Okay, 5 images. I'll show you the process on 5 images, and then you can follow the same steps for the other images of your dataset. So we have these 5 images and we want to annotate them. So you need some sort of tool which perform the annotation. So for my today's class, the tool which we are going to use is label img. Let me show you how to install that tool first and then how to use that tool. And here this folder, and I'm activating the environment, and let me show you the Python version. Pip install label img and hit enter. This tool will be installed on your machine. So I have already performed the step, so that's why we are seeing this requirement already satisfied. Now tool is installed. We need to open the tool and start annotating. So to open the tool, you will write label img and enter. It will open a desktop application like this, right? So here on the side you'll see a different options. So the first option is open directory. So we need to open the directory where our images are which we want to annotate. So click on open directory, then we'll go to the folder where our images are. So in this folder we have our images, right? Demo custom YOLO11, and this is the folder. Select this folder like this. You'll see the first image over here. Now just below that, here you can see this YOLO. So this YOLO selected means that the annotations will the annotation format which we have selected is YOLO. So let's say this is the another format, create ML. This is the Pascal walk format. So this format will save the annotation in XML format. But what we want to save the annotations in YOLO format. And guys, YOLO V8 or YOLO V9, YOLO V10, all these models have the annotations in the same format. So let's say if you have some dataset with you, older dataset, and that dataset works well with YOLO V8 or YOLO V9, so you can use the same dataset annotations for YOLO V10 also, because all these YOLO's model, they use same format of annotations of images. All right, so we have selected the YOLO over here. And then see, this is this option, create rect box. That means rectangle box. So how we create bounding boxes around the objects? We select it, and then you'll see this kind of black plus over here which is moving. Just drag it like this on the portion of the of the object which you want to have annotation for. So this is the object, and here you need to provide the name. So let's say we are providing this name, license plate. So this is the class name we want to provide. Click on OK, and this side you will see the name of that class. So in our today's class, we are working with the one class only, license plate. So this is the first image. Now you have to save the annotation. So for that you'll do Control S, and the annotation will be saved in the same form, path where your images are. Click on save. Now let's go to that folder only. Okay, so it is over here. See, so earlier we were having only images, but now we have created the annotation for the first image. So we have a text file with the same name. Right now let's open this text file, and here this is the annotation. So this 0 is the class index, and these 4 values are the bounding box coordinates. So this first is the center X and center Y value, and this is the height and width of the image. So this is how you get the annotations. So in this image we have single object, so that's why we have a single line for the single line of annotation. Let's say if there are 2 cars or 3 cars, then we will have a separate line for each object. I'll show you that in a minute. So we have the annotation for the first image. Now let's go back to the application again over here. Now this is an arrow, click on it and it will show you the next image. Now let's click on this create rect box again, and then select it and license plate. Okay, save it, Control S. Now let's go to the third image. So here, see, here we are seeing the license plate over here also, here and here. So create rect box, first create the bounding box for this, like this. Select the box again, select this, okay, and then for this. So now what will happen, we will see 3 div Control S. And now let's go back to the folder again and see for this image, this is the annotation. Open it and you will see the 3 lines. So first line is for the first object, second line is for the second object, third line is for the third object, and they all have class ID 0. Why the class ID is 0? Because we are detecting single class and the class name is license plate. So this is how you perform annotations. And now once you have the images and the annotations for all the images, what will you do? You just create a data folder. We'll create a data folder, and inside that create 3 folders. So you can do, let's just give the name train, and then just copy this twice, and then over here make it a test folder, and then you need to make third one is validation folder. So you need 3 folders. In train folder, we will place all the images and their corresponding annotations which we will use to train our model, and the images which are there in train folder and the images which are there in validation folder, they are separate images. We validate our model on different set of images just to see what kind of performance our model is giving, okay? And then in test folder you can have your test images and their corresponding annotations. So inside train, now you will create 2 folders. First folder name will be images, and then the second folder name will be labels. Now all the images you will place in the images folder, and their corresponding labels you will place in the labels folder. So let me just show you from here only. So this, so let's say this image and this image, these 2 images I want to place in the images of train folder, and the corresponding annotations of these images we will place in the labels folder, okay? So now go here and then this and this, copy them from here, and then you'll place it in the labels folder, okay? So this is how you prepare the dataset, and in the same way you can paste the images and their corresponding labels over here also. Inside val also you'll create the same folders, images and validations, but the images and labels over here will be different than the images and labels which are there in the training dataset. So guys, this is how you prepare your dataset, but for our today's class, we, as I've told you, we are using this dataset, and this dataset have this 10,126 images, and I've shown you how to download this dataset, and the link of this dataset is given in description section. You can download the same dataset if you want. Okay, now we have the dataset. Let me place this dataset over here. Copy this dataset from here. Then we are placing this dataset in the folder where we are testing. Okay, now let's extract the files. Now we have this. Now let's rename it license plate dataset. I have renamed this folder to this, and let's open this folder, and here you'll see the train, valid and test folder as I've shown you, and in each folder you'll see the images and labels. Inside images you'll see the images and their corresponding annotations you'll see in the labels folder, right? So this is our dataset, and with dataset you'll see this YAML file. This file is important because this file tells our model where our dataset is on which we want to train our model. Okay, let's open this file here. So this is the file. See, inside this train we will give the path of the training images. Here we will give the path of the validation images, and here we'll give the path of the test images. So our training images are here and train, and inside train there are images. Okay, so we will change it like this. So this is the path of our training images, this is the path of our validation images, and this is the path of our test images. And NC equals to 1 means we number of classes, so we have single class, and in names you will have your names of the classes. So let's say if you have 2 classes, let's say 2, and license plate, and the second class name is car, so you will write it like this. All right, so yeah, and that's it. So these parameters, these values are required, and let's sometime what happen is you provide the wrong path and you get wrong, you know, some sort of error. So make sure that you provide the correct path of the images over here. Right now our data.yaml file is also ready, and our dataset is here. So our dataset is this. Let me delete this one. Now our dataset is ready. Next task is to train the model. Now to train the model, first you need to set up the environment where you will run this code, right? So by setting up the environment, I simply means you should have all those modules installed which are required to run YOLO11, right? So for that, I have prepared this file env_setup. This is a text file. Let me open this file. So these are the steps which you need to perform. So guys, I always recommend to work under a separate environment. So this is the line which will create your separate environment, and this will be the environment name. You can change this name. You can, you know, put anything, whatever name you want to provide to your environment, you can write it over here. And I want to create this environment with Python 3.10. So you can work with any Python version. I'm just showing you the steps which I have followed to run this particular example which I'm showing you today. So if you want to use Python 3.10 like I have used, then make sure that you have downloaded and installed the Python 3.10 first on your PC. Then only this line will work for you. After that, using this line, we are activating the environment. And then guys, over here I'm installing the torch vision and torch audio manually first from the PyTorch official website, and then I'm installing the ultralytics package. So why I'm installing this torch vision and torch audio manually before installing the ultralytics package? Because we all have different PCs, and in all different PCs, persons have different kind of CUDA versions. Let's say my PC have a CUDA version 12.4 and your PC have a CUDA version 11.8 made and somebody's PC have CUDA version 11.6, right? So for different CUDA versions, you need a different torch version. So it is a best practice. It is better. It is recommended if you install the torch vision and torch audio first. So as per the CUDA version of your PC, and then you install ultralytics. So that way you can use the GPU of your machine. That way you can utilize the GPU of your machine. So these are the 4 steps you need to perform to set up the YOLO11 environment. Now your environment is ready. Let's open the command prompt and let's go to the drive, and now I'm entering in the folder where my code is. Now I am activating the environment. And how we activate the environment? Like this. First you write your environment name and then you write this and this. Okay, so let me activate the environment. So environment is activated, and this is how you can confirm if the environment is activated or not. Now I'm opening the Jupyter notebook. I will show you the steps on a Jupyter notebook. So to open a Jupyter notebook, you will write this and Jupyter notebook will open. So this is the Jupyter notebook, and this is the folder which I've told you that we are working inside it. And this is our dataset, and this is the file which I've shown you where I have mentioned all the steps, right? So let's create a file over here, new Python 3, and this is how you create a file, and here we will write the code. So how we train a model? This is the script for it. First we are importing YOLO from Ultralytics, and then we are using the YOLO 11 pre-trained model, and then we are not training the model from scratch, because if you'll train your model from scratch, that will take more time to make your model better. So here what we are doing is we will use the pre-trained model, and then we are fine-tuning that pre-trained model on a custom data set. That way you can work better with your custom problems. Okay, so this is the link of the pre-trained model. And guys, when we will execute this cell, this pre-trained model will be downloaded in your current working directory itself only. There is no need of a manual step. So, and here we are writing the parameters which are required to train the model on a custom dataset. First one is the path of your dataset. So this is the path of my data.yaml file. Remember, we have this file in this folder. And let me show you once again. Okay, it is here in license plate dataset. This is a dataset. Inside it we have this data.yaml file, right? So that path we have provided over here, right? So in this file we have mentioned where our training images are, where our test images are, and where our validation images are. So this is how you provide the path of your dataset, and we want to train this model for 5 epochs only. You can train the model for more epochs, but this is just for a testing purpose. So I'm just training the model for 5 epochs, and the image size is 640 device 0. Device 0 simply means I want to train my model on GPU, and in case if you want to test this code on CPU, so you will write CPU over here, and when I'll hit enter, this will create. Okay, let's hit enter and see. So let me open this folder also over here. See, when this part started over here, we got this runs folder, and inside this runs folder we are getting this detect folder, and inside this detect we have a train folder. And now whatever training is going to happen, our trained model and all the accuracies and the map values, confusion metrics, everything will be saved over here. Okay, so let's go over here, and here you can see the Ultralytics version is this which I'm using. So I'm using Python 3.10, and this is the torch version, and my torch is compiled with CUDA 12.1, and this is the GPU which I'm using. Now let's just scroll down, and here you'll see that it is scanning the training images and the validation images. Now it is scanning validation images, right? Now it will start training in some time. Till the time, let's go back to this folder. This is the place where we are working, right? here, and here I'm just pasting two more folders, this test images and test videos. So this test images folder just have few images on which we will perform the testing. Once our model will be trained, we will test our model on this, and inside the test videos I have placed few videos on which we will perform the testing. Okay, so let me see if the training started. Okay, see, now the training has started. So guys, this is how you train your model. This step will take some time to train the model for 5 epochs. So I have already performed this step and I already have that trained model. Let me open that trained model and we will perform the testing using that model. Okay, so for that, this is what you'll see after the training when 5 epochs will be done. And let's see the confusion matrix. So this is the confusion matrix, right? And then if you will see this results, here you can see the map value when the threshold value is 50 and the map value when threshold value is between 50 to 95, right? Here you can see our model is performing, the map value is around 98, 99 when the threshold value is 50. But when the threshold value is between 50 to 95, at that time our map value is around 0.66. right? And then if you want to, this kind of folder you will get, and inside this you will see the best.pt. Using this model we will perform the testing on the images and the video. Now let's see how to do that. So now to test the model, we'll write this. We are importing YOLO and this is the path of the model. So inside run we have this, remember here inside run, detect, train, this is weights and this is the model we want to use. So this path we have provided over here, a custom model, and then we are providing the path of the image on which we want to perform the testing. Let's run it. So here license plate 0.72, this is the confidence code and this is the class name. And why we are seeing this output on the screen? Because we have used this dot show. Now what if you want to save this image in a folder, right? So for that you will write this, save equals to true, and let's run it. So it will show you the output image over here and it will also save the output image in the runs folder. Now let's open it and see. See, we will get this predict folder inside the runs detect folder when you will open it, and here you will see the output image. Now let's work with some other sources. Now let's say instead of working on a single image, you want to test the model on all the images of a folder. So we'll give the path of the folder where our images are. So remember in a few minutes back only I've told you that we have pasted this test images folder in this folder, and here we have these many different images. Now we want to perform the testing on all these images at once. So for that you just need to give the path of the folder and hit enter. Now all these images are stored in predict2 folder. Now let's open the predict2 folder here and see the output images. See, this is the first image, second image, here you can see the license plates are getting detected. All right, so this is how we work with the images. Now let's see how to work with video. So to work with video, what you'll do, just copy the same code again. So there is no need to load the model again and again because we have loaded the model once. So you just give the path of the video. So in my test videos folder, let me see the name of the video. Okay, here we have another folder with the name of test videos. Inside that we have these videos. Let's test on this first one only. So 1.mp4 and save true will save the result. Let's run it. So output video is stored in predict3. Let's open predict3 folder and let's check the output video. Here you can see the license plate is getting detected, right? Now let's say if we want to test multiple videos at once, right? So for that we will do, let's go to the folder again, and instead of writing like this, just give the path of the folder where our videos are. So all our videos are in this folder. See, all our videos, we have these many different videos in the test videos folder, and we want to perform the testing on all those videos. Just click on it and it will process all the videos one by one, and finally you'll see the output video. And let me show you the output. Let's go back here, runs, detect. You will get a predict for folder. First video we have already seen, so let's see the second one. Okay, it is under process right now. Okay, now let's check. So this is our second video. Right, now let's see the next video. It is processing right now, so let's wait for a second. Let me see here. So here all the videos are getting processed one by one. Okay, so let's see the third one. So this is the third video. Now let's see the fourth one. And then the fifth one. So guys, here you'll note that some of the time our model is not detecting properly. So that's because we have only trained the model for 5 epochs. You can improve your model by training your model for more epochs, and that way you can improve the result of your model. So this is how you perform training and testing on a custom dataset. I have provided the link of Dataset, and I have also provided the link of my GitHub, so you can try this code yourself. And I hope this video is helpful. So guys, if you like my content, please like, share and subscribe my channel. Thank you for watching.